Hey y'all! This video is part 2 of my mini-series on surfacing this Douglas Fir slab on my Avid 4848 Pro CNC router. In the last video, we flattened this side to get a nice even surface. And I did that manually using MDI commands and incremental jogging to get this surfaced nice and flat. In this video, we're going to flip this piece over and we're going to create a toolpath to machine this slab down to its final thickness. We'll be creating two toolpaths. One will set to the material surface and the other will set to the machine bed. Now, before I can go inside and start calculating the toolpath, I need to find out how thick this piece of material is right now, the way it's mounted to this spoilboard. Keep in mind that we used these shims to steady this piece of material as it had developed a cut in it. So I'll need to measure its thickness as it sits right now, then flip it over and mount it so I can machine it. Here in the software, we'll need to go ahead and create a new file. Now, before I do that, let me say that even though I'm demonstrating this in Aspire version 11.5, this works identically in Cut2D and VCarve, both desktop and Pro. So we'll go ahead and we'll create a new file. Now, I've already done this once before, so my measurements are already in my job setup form. If you remember that slab, it has an odd shape to it. The widest part of that slab is 17.5 inches wide in X. However, because of that strange shape and some protrusions hanging out to either side of the slab, I'm going to go ahead and make it 19 inches wide. That way it'll cover the entire slab. It is almost but not quite 31 inches long, so I went ahead and entered 31 inches as the height in Y. For my thickness, after I flattened the first side, I took a measurement and I came up with 1.36 inches thick. So we'll enter that as our material thickness. For the Z0 position, I'm going to show you two ways of doing this, and I will use both toolpaths when we get out on the machine and I demonstrate this. For the first demonstration, I'm going to set my Z0 to the material surface. For the second demonstration, I'll set it for the machine bed. More on this in a couple of minutes. I'm going to set my XY datum to the center of the material. Modeling resolution will stay at standard because there are no 3D components in this project at all. We'll click OK. Now, the first thing I'm going to want to do is create a vector that my toolpath is going to follow when we surface this material. So I'll come up here to draw a rectangle, and I want to use the center of this rectangle as my anchor point, and I want the center anchored to my X0, Y0, right here in the middle. I want square corners, and for my width, I want the bit to come off about 1/2 inch from each side. So the way I'm going to determine the width of this rectangle is I'm going to come up here and highlight whatever value is in my X blank, and I'm going to type in X plus 1, which is the width of my material in X that I just put into job setup, plus 1 inch. And then I'll tap the equals button on my keyboard. and that gives me the width of my rectangle in X. For my height in Y, the material is just shy of 31 inches. Now, my surfacing bit has a 2-inch cutting diameter, and I want that bit to come off of the front edge of the material and off of the back edge of the material, the diameter of my bit, because I want all the X moves to happen out here off of the material. That leaves a smoother surface. So, for my height in Y, I'm going to say Y plus 4 equals 4 inches, because I want 2 inches up here and 2 inches down here. I'll click Create, and there is the vector that my toolpath is going to follow. I'll click Close. For this project, as I said, I'm going to show you 2 separate ways, so I'm going to create a second sheet identical to this one. For that, I'll come down here to my Sheets tab. If you have your tabs on the left side, the Sheets tab will be somewhere in this area. Now, a word about Sheets. Sheets were introduced in version 11.0. If you're using version 10.5 or earlier, you can't take advantage of Sheets. You will have to make a separate file for each one. But because we have Sheets available to us, I'm going to create a new sheet. I'll just come down here and click Add New. And that has added a second sheet. And we can see here the name of the sheet is highlighted. The X measurements are identical, the Y measurements are identical, and the Z measurements are identical. For this second sheet, I'm going to use the machine bed as my Z0 position. So I'm going to go ahead and rename this now Machine Bed and hit Enter. Then I'm going to come down and select Sheet 1, right-click, and I'm going to rename this Material Surface and hit Enter. Now I have 2 separate sheets that are identical in size. Now that I have my machine bed material created, I'm going to come up here and select it so that it is active. Then I'll come down and I'll click Edit. And here I can make any changes up here should I need to, which I don't want to do in this case, but I'm going to set my Z0 position to the machine bed. And that will affect this sheet only. Now again, if you're using version 10.5 or earlier, you can't take advantage of this. You will have to make a separate file. I'll click OK. And we now have our 2 sheets. One with the Z0 position set at the machine bed, and the other with the Z0 position set at the material surface. Now I'm going to come back over to my Drawing tab. I'm going to select this outside vector that we just created. Then I'll right-click, Copy to Sheet, Machine Bed. So now I have the same vector on both sheets. We're ready to calculate the toolpath. We'll head over to the Toolpath tab. I'll select the vector, and I want to select a pocket toolpath. So we'll come up here to Pocket. Follow me on this. It's going to sound counterintuitive, but I will demonstrate what I'm doing when we get outside on the CNC router. For my start depth, for the material surface sheet, I'll enter 0. For a cut depth, I'll enter 0. I'm using my 2-inch Amana RC2255 bit. I want to use a raster machining strategy. If I just use a raster angle of 0, the bit's going to go back and forth from side to side along the X. I prefer to machine bottom to top, top to bottom along the Y. I have a raster angle of 90 degrees set. I also have my profile pass set to no profile pass. Now I'll come down here and name this material surface and calculate. Now, if we take a look, we'll see the bit will come from my XY0 up to this corner, then plunge down to the material surface, and then start moving back and forth, making its X moves out here off of the material, which is exactly what I want. I'm not going to preview it simply because you wouldn't see anything. All you would see is an animated preview of the tool moving back and forth. So I'm not going to bother previewing. I'll just close this. And now I'm going to save this toolpath. So we'll come up here to save toolpath. And I'll save this visible toolpath to one file. Here's my bit. Here is the machine I'm using. Here is my post processor. I'll go ahead and save the toolpath. I have my thumb drive installed in my computer, and what I'm going to do is rename this file. I'm going to call it Doug Fir Material Surface. That's letting me know that my Z0 position is the material surface. Then I'll click Save. So that one toolpath is finished. We're done. Now I can uncheck it, close this, and now I can switch over to my other sheet, which is the machine bed. Out here in the 2D view, the machine bed sheet is active. I will select the vector, and I'll do the same thing. I'll come up here to the pocket toolpath. Now for this toolpath, I am going to need a cut depth. And I'm going to go slowly through this so you can follow the logic on how this is done. My material thickness is approximately 1.36 inches. What I want is I want to end up with a thickness of about 1 1/8 inches, which is 1.125 inches. As we saw outside, the surface that I'm going to be machining with this toolpath is not flat. So that's about the thickest I think I'm going to be able to get out of this. It may end up being a little more, it may end up being a little bit less. But the way I'm going to figure out my cut depth is I'm going to take what I believe to be the material thickness now. I'm going to enter 1.36. From here, I want to subtract the final thickness I want. So I'll subtract 1.125. Then I'll tap the equals button. And that gives me a cut depth of 0.235 inches. Take your actual thickness, subtract the final thickness you want, then tap equals. That is your cut depth. Again, I'm using my Amana RC2255 surfacing bit. And the settings for this bit, if we come in here and take a look, the pass depth, as suggested by Amana, is 1/8 of an inch. I know that this tool is capable of cutting that depth with no issue. I also know that my machine is capable of cutting that depth with no issue. But I want to be just a little bit gentler with this toolpath, because it's not a nice, flat, even surface with no defects. There are knots, there are surface defects that could get knocked loose and become a projectile if I try to be really aggressive with this. So, as it sits right now, it's close enough to 1/4 of an inch of material I'm going to be removing. The software is setting this for 2 passes. Again, I don't want to be that aggressive. So I'm going to come over here and edit passes. And we can see it wants to take not quite 1/8 of an inch off per pass, but I want to reduce that. So I'll hit 3. Now I'll increase it to 4 passes. So it's going to be a little bit more gentle. Now, each pass isn't going to take very long, but I'll be able to kind of keep an eye on it and make sure nothing comes dislodged or I'm not shredding the edges off of this piece of material. I'll click OK, and we now see it's going to do this in 4 passes. Again, I'm going to use a raster machining strategy with a raster angle of 90 degrees with no profile pass. Now I'll come down here and I will name this machine bed, and I'll calculate the toolpath. Now I can go ahead and preview this, and we'll do that right now. With our toolpath complete, we can come over here and put our cursor over the surface. And if you look down here at the readouts, the digital readouts that are going to pop up, you can see that our Z height is 1.125. And that's exactly what we want. Now, this is a theoretical Z height. It's going to depend on how we mount our material, as well as a couple of other factors. Now, I'm not looking for spot-on laser precision here. I'm looking for as close to that 1.125 as I can get. It is not critical, but I'd like to get as close to that as I can. Now, our preview is done. We can go ahead and reset it. And I can close this. Now I can save this toolpath. So we'll go ahead and select it to make it visible. I'll click Save Toolpath. Again, visible toolpath to one file using this bit. I have the correct machine, the correct post processor, and I'll save the toolpath. I'm going to go to the same folder on my thumb drive, and I'm going to again change the name to Doug Fir Machine Bed, letting me know that this toolpath, the Z0 position, is the machine bed. And I'll save it. Go ahead and close this and deselect. Now I'm ready to take my thumb drive out of the computer and take it outside, and we'll get on the machine and we'll start surfacing this Douglas Fir slab. And there we go. My Douglas Fir slab has been machined down to 1 1/8 inches thick. Now I can carry on by filling some of these cracks and knot holes with epoxy and continue on with the rest of the project. So I hope you got something out of this video. And if you did, I hope you'll give it a thumbs up. Oh, wait a minute. Why did I create that second toolpath with the Z0 set to the material surface? Well, simply put, I did that just in case. What I mean by that is, if I had made a mistake in my measurements and this was too thick, or if I had left it sitting out here in the shop for too long and it developed a cup again, I could flip the material over and mount it, set my Z0 to the material surface, and then just like I did in part 1 of this series, bring the bit off of the material, drop the Z0 down to 0, then use MDI to drop it down a little bit more, however much I needed to shave off. Set my 0 again and let the machine, the G-code, do the machine. By setting my Z0 position to the surface of the material, then setting a cut depth of 0, I can use MDI to put that bit anywhere I want it to, then cycle start that G-code, and it will surface at that level. So again, I hope you got something out of this video. And if you did, I do hope you'll give me a thumbs up. Now I know there's going to be a lot of questions about this process. So this afternoon at noon Pacific, 3 p.m. Eastern, I'll be hosting a live Q&A session where you can ask me any question you'd like about anything I presented in this video or any of my previous videos. That's this afternoon at noon Pacific, 3 p.m. Eastern, right here on my YouTube channel, and I put a link to that live Q&A down in the description box of this video. Before I wrap this up, I would like to give a special shout out and say a special thank you to all of my channel members. Thank you very much. If you'd like some information on how to become a channel member, just click that join button down next to that subscribe button. A panel will pop up and a video will play that'll tell you all about channel membership. So, I hope to see you this afternoon for the live Q&A session. And as always, whether you subscribe to my channel or not, whether you become a channel member or not, I'd like to thank you very much for taking the time to watch. And y'all take care.